The weather. That obnoxious yet lovable phenomenon that shows up to ruin picnics. Frizz your hair. Or occasionally hurl frozen water at your face while pretending it's doing you a favor. Have you ever looked up at the sky and thought, what on earth is going on up there? Where storms come from? Or clouds? Wind? Or rain? Why thunder sounds like the clouds are bowling? Why the sky's tossing ice cubes at your forehead? Where the heck the northern lights come from, or tornadoes? Hurricanes? Why some parts of Earth have 4 seasons? If it's true, you can find the end of the rainbow. If so, don't worry. Dear dreamer, I've got you covered tonight. Technically speaking, weather is the state of the atmosphere at a particular time and place. It's the combo meal of temperature, humidity, wind, cloudiness, visibility, and whatever nonsense water decides to do that day. Rain, snow, hail, sideways mist, crying dramatically onto your laundry. Weather is temporary, fleeting, petty, unlike its cousin, climate, who wears tweed and writes strongly worded letters. Weather just shows up, acts out, and disappears. Let's zoom out. Picture the Earth wrapped in an invisible snuggie of gas. That's the atmosphere. Keeps us warm, shields us from space horrors, and holds in the air we breathe. But it's not just sitting there quietly. No, it's constantly moving, shifting, swirling. The sun heats the Earth unevenly because the sun is lazy and doesn't read instructions. So, some parts warm up more than others. Warm air rises, cool air sinks, water vapor sneaks into the mix. The Earth spins like a drunk ballerina. This causes pressure systems to form, winds to blow, and clouds to gather for their daily drama sessions. That's weather. It's all just molecules throwing tiny tantrums in the sky. What makes weather happen? A series of bad ideas. Let's break down the culprits. The sun. This big flaming gas ball is our main source of energy. It heats things unevenly. Tropics get roasted. Poles get ghosted. Boom. Chaos ensues. Air pressure. High-pressure systems are like that friend who's always chill and doesn't start fights. Low-pressure systems are moody and can spiral into full-on atmospheric melodrama. Water. Water, the diva of the atmosphere, can exist as a gas, liquid, or solid. It changes state constantly, releases or absorbs heat, and basically fuels most weather events. The Earth's rotation. This causes the Coriolis effect, which sounds fancy, but just means stuff spins weird. It makes storms rotate, messes with wind patterns and adds flair. Topography, mountains, oceans, valleys. All the Earth's lumps and bumps affect how weather flows. Mountains block rain. Oceans feed storms. Deserts throw tantrums of heat. Together, these ingredients mix and mingle in an endless cosmic cocktail party. Humans have been yelling at the sky for millennia. Ancient civilizations built temples to appease rain gods. Sailors used wind patterns to cross oceans and occasionally get horribly lost. Farmers watched the clouds like stockbrokers watch the market. Eventually, we invented meteorology, which is just a fancy term for weather science. It started with observing the skies and scribbling on parchment. Now it involves satellites, computer models, and professors ranting into microphones about atmospheric instability. Weather versus climate. Sibling rivalry with thermometers. Now we're diving into a heated family feud. Weather versus climate. 2 atmospheric siblings. One is chaotic and moody. The other holds grudges for centuries. Now, I know what you're thinking. But Chris, aren't weather and climate the same thing? Nope. That's like saying a Fruitly is the same as a fruitcake. One is short-lived and unpredictable. The other is dense, seasonal, and can be weaponized. Let's begin. Weather is today's temperature, whether it rains or not. That gust of wind that just blew your sandwich into the neighbor's koi pond. The cloud that looks like a dinosaur and brings a storm just to spite you. It's the moment-by-moment emotional breakdown of the atmosphere like a toddler in a sugar crash. Weather changes fast. Blink and it's different. Sometimes literally. Climate is the big picture. The average. The trend. It's the result of weather throwing a tantrum every single day for 30 years straight. And then we look at all those tantrums and go, seems a bit warm lately. Climate is what winters are usually like in your region. The expected rainfall over decades. Long-term temperature averages. Patterns that whisper, I'm not mad. I'm just disappointed. Climate is the older sibling that got a master's degree, moved abroad and sends letters about your life choices. Let's put it this way. Weather is your mood. Grumpy in the morning. Euphoric after tacos. Climate is your personality. Sarcastic. Overly fond of cardigans. Mild seasonal existential dread. Your mood can change hourly. Your personality stays relatively stable over years. Unless you suddenly move to Finland or adopt 3 cats. Then all bets are off. Meteorologists use satellites, weather balloons, and ground stations to measure weather in real time. Climatologists, on the other hand, use historical data, scores, ancient climate popsicles, tree rings. Trees keep petty little weather diaries, ocean sediment, computer models that require more processing power than your average space probe. They're less. What's the forecast? And more. How screwed are we long-term? If you confuse weather and climate, you end up saying things like, wow, it snowed today. Guess global warming is a hoax. No, Karen, that's not how any of this works. A cold day doesn't cancel out decades of rising global temperatures. It's like biting into one spicy pepper and claiming the entire cuisine is bland. Weather is noisy. Climate is the melody underneath. Let's say you spot a penguin sunbathing under a palm tree. Confusing. Yes. But maybe it's just weather. A freak heat wave in Antarctica. One-off. Strange. But not impossible. But if over decades penguins start wearing sunglasses and opening tiki bars, now we're talking climate change. Let's talk climate change versus climate variability. This part gets subtle. So pay attention. Sleepy darling. Climate variability is the natural ups and downs. El Niño, La Niña, volcanic burps, solar wobbles. Climate change is a persistent shift, often due to humans burning things we probably shouldn't burn, like fossil fuels or questionable cheese. Variability is the swing. Change is when the whole playground shifts uphill. Climatologists usually look at 30-year averages to define climate. That's enough time to smooth out weird blips. So, if it's oddly warm one summer, that's weather. If it's oddly warm every summer for decades, that's climate change tapping on your window with a we need to talk look. We can predict weather fairly well a few days ahead. Sometimes even a week if the atmosphere is feeling cooperative. But climate forecasts look decades into the future. They involve projections. If emissions stay high, expect more heat waves. If we plant more trees, we might chill out the planet a bit. It's less about daily details and more about preparing humanity not to boil itself alive. Understanding the difference between weather and climate isn't just cocktail party trivia. The survival. Weather affects your day. Climate affects your future. The better we understand both, the smarter we can be about living on this blue marble hurtling through space. Seasons, the Earth's fabulous tilted catwalk walk. Now, dear dreamer, we are going to talk about seasons, not the kind you sprinkle on potatoes. Mind you, I'm talking spring, summer, autumn, and winter. Nature's fashion line sashaying down the cosmic runway with style. attitude, and the occasional snowplow. Now, many people think seasons happen because the Earth gets closer or farther from the sun, which is adorable and wrong. In truth, the planet is a bit of a show-off. It's tilted about 23.5 degrees or vertical to be precise. That may not sound like much, but when you're a giant rotating sphere spinning through space at dizzying speeds, it's enough to cause a global identity crisis every few months. So, here's how it works. Picture Earth orbiting the sun like an anxious parent circling a busy playground. But it's doing so while leaning slightly to one side, like it's trying to listen in on gossip from another galaxy. That tilt never changes direction relative to space, which means depending on where Earth is in its orbit, one hemisphere gets more sunlight than the other. When your half is pointed toward the sun, boom. Summer when it's leaning away. Bundle up. It's winter. Spring and autumn are those moody transition phases when the planet can't quite decide what to wear. This tilt gives us longer days in summer and shorter ones in winter. It affects the angle at which sunlight hits your patch of the planet. Steeper angles in summer mean more direct warmth, like getting blasted by a heat lamp. Shallower angles in winter mean the sun is low in the sky, sulking like a teenager who didn't get concert tickets. And here's where it gets interesting. The northern and southern hemispheres do everything in reverse. When it's summer in Paris, it's winter in Patagonia, while children in Canada are building snowmen. Kids in Australia are frying eggs on car bonnets. It's a global seesaw, perfectly balanced, occasionally wobbly, but always in motion. The equator, ever the peacemaker, doesn't have dramatic seasons. It stays pretty consistent year-round. Tropical places near the equator might experience wet and dry seasons instead of hot and cold ones. So instead of debating which coat to wear, they're deciding whether to carry an umbrella or an inflatable raft. Seasons are also behind some of nature's greatest performances. Migrating birds, flowering plants, hibernating bears. They're all operating on Earth's seasonal cues. Even your mood might shift with the seasons. There's something deeply human about the first warm breeze after a long winter, or the crisp smell of autumn leaves as they crunch dramatically under your boots, making you feel like the brooding protagonist in a low-budget indie film. Of course, humans have tried to tame the seasons with calendars and holidays. Solstices and equinoxes mark the official starts of seasons based on the position of the sun. The summer solstice is the longest day of the year, a triumphant moment when the sun struts across the sky like it owns the place. The winter solstice, on the other hand, is the shortest day. Blink and it's over, a fare best spent in pajamas with hot beverages. Equinoxes are when day and night are roughly equal, a fleeting moment of planetary balance. They happen twice a year, once in spring and once in autumn. The Earth, for just a heartbeat, stops being dramatic and shares the light equally. A rare moment of cosmic diplomacy. And what about the peculiar personalities of each season? Spring is the hopeful optimist waking up early, shaking off the frost, and insisting everything's going to be fine. Flowers bloom, birds sing, and people pretend allergies don't exist. Summer is the extrovert, loud and sweaty, full of energy and slightly dangerous if left unsupervised. Autumn is the moody poet, rich in color and quiet reflection, always on the verge of releasing an acoustic album. Winter. Winter is the introvert in thick socks who stays home and judges everyone from a frosted window. Not all places on Earth experience all four seasons, though. Near the poles, you get extreme versions. Months of sunlight followed by months of darkness. Meanwhile, tropical regions just laugh gently and continue having fruit smoothies year-round. But wherever you are, the rhythm of the seasons shapes the natural world around you. It influences food, festivals, migrations, and even love. Yes, Love. There's a reason people fall for each other in spring. Something about longer days and pheromones and the way pollen sticks to your eyelashes. Climate change, of course, is now messing with this ancient rhythm. Winters are warmer. Springs come early. Summers get outrageous. Autumn barely texts you anymore. The reliable old seasonal script is being rewritten. And not always in ways we understand yet. But we'll get into that in later chapters. For now, sleep gently, knowing that the Earth continues its slow, graceful orbit around the sun, tilted just enough to keep things interesting. So, the next time you wonder why it's suddenly dark at 400 p.m., or why everyone in your neighborhood is wearing shorts in October, remember it's not random. It's the Earth doing its cosmic twirl, tilting like a diva in heels, ensuring that no part of the planet ever gets too comfortable for too long. Air pressure. The invisible hug that sometimes squeezes too hard. I know it sounds about as thrilling as a sock draw. But trust me, air pressure is the unsung hero of weather. It's the great puppet master pulling strings you can't see but absolutely feel. It's what makes the wind blow, the rainfall, and your ears pop on airplanes. It's everywhere and it's clingy. Let's begin with the basics. Despite its ghostly invisibility, has mass. It's made of molecules, mostly nitrogen, some oxygen, and a dash of miscellaneous gases with fancy names. These molecules, bless their little hearts, are constantly bouncing around like overcaffeinated toddlers at a trampoline park. They collide with everything, including you, all the time, every second, and all that bouncing, all that invisible molecular chaos. That's pressure. Air pressure is simply the weight of the atmosphere pressing down on the Earth's surface. And I mean weight, literally. The entire column of air above your head from ground level up to the edge of space has mass. That mass exerts force. A lot of it. Every square inch of your body is under about 14.7 pounds of atmospheric pressure at sea level. That's like having an invisible bowling ball sitting on every inch of you. Which sounds horrifying until you realize you're used to it. Your body is basically a pressurized meat balloon. Now, the thing about air pressure is that it's not the same everywhere. Some parts of the atmosphere are dense and heavy, high pressure. Others are light and flimsy, low pressure. And when there's a difference between the two, that's when things start to move. Let me paint a picture. Imagine the atmosphere as a room full of pushy grandmothers. I know, random, but bear with me. The high-pressure grandmas have too many cookies and insist on giving them away. The low-pressure grandmas are cookie-starved and beckoning. Naturally, there's a rush of cookies and air moving from high to low. That movement, that's wind. High pressure usually means calm, settled weather. The atmosphere is heavy like a thick duvet, smothering cloud formation and keeping things chill. Low pressure, on the other hand, is where the fun or mayhem happens. Rising air cools, condenses, forms clouds, and suddenly you've got storms throwing a hissy fit. The highs and lows on your weather map. That's meteorologists tracking pressure systems. The big H's and L's swirling around like they're playing some elaborate game of sky chess. Those are your pressure systems in action. Highs drift slowly, lazily, spreading sunshine and stability. Lows spin like caffeinated ballerinas, bringing clouds, wind, and mood swings. Air pressure also changes with altitude. The higher you go, the less atmosphere is above you, so the pressure drops. That's why hikers get breathless. Planes need pressurized cabins and mountaintop cafes serve suspiciously flat cake. Your lungs are used to a certain pressure party. Take them too high and the guest list thins out. Have you ever felt your ears pop when you drive up a mountain or land in an airplane? That's your inner ear trying to equalize the pressure between your insides and the outside world. is a strange reminder that you're not just existing in the atmosphere. You're part of it. A squishy barometer in sensible shoes. Now, if you're wondering how we measure this mysterious force, allow me to introduce the barometer. It's an instrument that's been around since the 1600s. And no, it does not involve baristas or foam art. The earliest barometers used mercury, which is heavy, toxic, and loved by mad scientists. It's a glass tube sealed at the top and open at the bottom. It's filled with mercury and inverted into a reservoir of mercury. Atmospheric pressure pushes down on the mercury in the reservoir, causing the mercury in the tube to rise or fall. The height of the mercury column is directly related to the atmospheric pressure. Today's versions often use anoid capsules or electronic sensors. Anoid barometer is a sealed flexible metal chamber anoid cell partially evacuated of air. Changes in atmospheric pressure cause the chamber to expand or contract. This movement is transferred to a needle on a dial indicating the pressure. Different toys, but the principle remains. When pressure changes, something inside the barometer moves. That movement tells us what's going on in the sky. As a general rule of thumb, falling pressure means stormy weather is on the way, and rising pressure means things are settling down. Atmospheric pressure can also make you feel a bit odd. Some people get headaches or joint pain when pressure drops. Others swear they can smell rain coming. Animals, especially cats, seem to develop psychic abilities before a storm. Let's not forget the role air pressure plays in extreme weather. Hurricanes. They form around areas of very low pressure like giant atmospheric whirlpools sucking in moisture and spinning it into destruction. Tornadoes also pressure-driven. Even gentle rain showers are orchestrated by subtle shifts in pressure. In a way, air pressure is the emotional barometer of the planet. When it's high, things are peaceful, sunlit, composed. When it's low, all bets are off. It's the ultimate atmospheric mood ring, shifting constantly, affecting everything, and rarely noticed unless you're paying attention or trying to have a picnic. So, next time you look up at the sky and wonder what the weather's plotting, remember it all starts with a push or a pull, the invisible hand of pressure guiding the winds, cradling the clouds, squeezing your eardrums. Wind, the planet's breath, tantrum, and interpretive dance all rolled into one. Now, wind might seem simple. Air moves. So what? But oh, darling, wind is anything but simple. Wind is born from pressure imbalances in the atmosphere. Sure, but then it gets dramatic. Curves, twists, it whispers, it roars, picks up hats, delivers pollen, powers turbines, and sometimes when it's feeling extra, it becomes a full-blown howling tempest that knocks out your Wi-Fi. Let's start with where wind comes from. Imagine the atmosphere is a massive, ever-shifting playground. Remember air pressure from the previous chapter. High-pressure air wants to move into low-pressure zones because nature abhors a vacuum and air hates being crowded. So it flows from high to low. But because Earth is a spinning diva, this movement isn't straightforward. Curves. This lovely twist is due to the Coriolis effect. The same force that makes storms spin and toilets flush differently depending on which hemisphere you're in. Except the toilet thing is mostly urban legend. We'll let it slide. So air moves, then it curves, then it speeds up, depending on how big the pressure difference is. A gentle difference makes a breeze, the kind that flutters curtains and carries the scent of toast across the street. A massive difference turns that breeze into a gale, a storm, or in certain cases, something that makes you question your life choices as your umbrella inverts like a dead spider. Wind has personality. There's the sultry sea breeze drifting from ocean to land as the land heats up during the day. There's the land breeze which reverses the flow after sunset when the land cools faster than the sea. Then you have mountain winds sneaking down slopes like cold soup through a tilted bowl and valley breezes. warm air rising up from narrow spaces like the earth sighing in its sleep. Let's not forget the truly wild ones. Katabatic winds are dense cold gusts that slide off high-altitude ice sheets like a ghost army on rollerblades. Chinooks, the snow-eating warm winds of the Rockies, are known for turning blizzards into picnics within hours. And who could ignore the Jetreem? That's wind on an international business trip. High up in the atmosphere, jetreams are narrow bands of intense wind. Fast, focused, moody, they guide weather systems, influence airline routes, and occasionally throw the climate into a blender. Wind shapes our world in quiet and dramatic ways. Deritus rock, spreads seeds, drives ocean currents, and helps pollinate the daisies. As a courier, a sculptor, a messenger from distant lands. And yet, it's invisible. You can't see it. Only what it does. Like love or Wi-Fi, humans have spent centuries trying to understand wind. Ancient mariners watched it like hawks. Farmers learned its rhythms. Today, meteorologists track it with radar, satellites, and their uncanny ability to squint meaningfully at trees. We use wind vanes, anemometers, and occasionally inflatable tube men in parking lots flapping about like interpretive dancers of the forecast. Of course, not all wind is welcome. When it gets pushy, when it gets dangerous, it becomes a force of destruction. Think hurricanes, tornadoes, dreados, and these are winds gone rogue. High-pressure drama spiraling out of control. We'll cover them in later chapters with popcorn and a storm shelter. But for now, let's stay in the realm of gentle gusts and powerful breezes. The kind that hoo across open fields and whisper through trees. The kind that spins a child's pinwheel, lifts a kite skyward, or cools your face on a hot day. There's something almost magical about lying in bed listening to the wind outside. The way it swirls around your home like a protective spirit or a very insistent sales rep. And the way it sings through the chimney or brushes against the windows, reminding you that the world is still moving, still breathing even while you rest. So, curl up, close your eyes, and picture the air outside, rushing over rooftops, sweeping through streets, making leaves dance, and clouds meander. It's ancient, it's restless, and it never stops. Clouds, sky gossip in fluffy form. Now, dear dreamer, we ascend. We're looking up at the sky soft, moody, theatrical fluff. Clouds, or as I like to call them, the weather's gossip columnists. Always hovering, always shifting, always up to something. Clouds are one of those everyday miracles we take for granted. Floating water vapor sculpted by invisible forces. Drifting miles above our heads like lazy ghosts in a celestial waiting room. Some are gentle and poetic. Others are brewing trouble behind that serene facade. Every cloud has a story. And tonight I'll spill the tea. Let's start with what clouds actually are. In their most basic form, clouds are just tiny droplets of liquid water or ice crystals suspended in the atmosphere. That's it. That's the whole trick. Moisture in the air rises, cools, condenses, and poof, you've got a cloud. Like nature's own version of a surprise party. But not all clouds are created equal. No. The sky has categories. There are high clouds, middle clouds, low clouds, and the ones that refuse to commit to a height and just do whatever they want. High clouds, like cirrus, are the wispy overachievers. They float way up where planes cruise, made mostly of ice crystals. They don't do much in terms of weather, but they're fabulous to look at. If clouds were fashion icons, cirrus would be the ones in vintage scarves and opera gloves. Middle clouds, alteratus, and alterumulus are moodier. They signal that something might be brewing. They're the teenagers of the sky. Not quite low, not quite high. always preparing a dramatic monologue. Low clouds are where the action happens. Stratus, Nimbratus, and the cumulus bunch. They bring the rain, block the sun, and sulk dramatically over the horizon. Stratus clouds are like a gray wool blanket your grandma insisted on. Nimbus stratus. That's the one that rains for 8 hours straight. Like it's going through something. And cumulus. Cumulus. Puffy. Friendly. Cartoon-like. The standard cloud in every child's drawing. Don't let their charm fool you, though. Give them enough heat and moisture and they'll bulk up into cumulus congestus or the infamous cumulonimbus. The thunderstorm factory. Yes. Cumulonimbus. The towering menace. The sky's equivalent of a bar brawl. These clouds stretch miles into the atmosphere, forming anvils and hiding lightning in their folds. But why do clouds form in such dramatic shapes? It's all about rising air and stability or lack thereof. Warm air rises. As it ascends, cools. Cool air can't hold as much water vapor. So the vapor condenses into droplets. That's the birth of a cloud. The more rising air you've got, the bigger and bolder the cloud becomes. If the atmosphere is stable, the cloud flattens out. And if it's unstable, the cloud keeps rising like it's got something to prove. Clouds also move. They're passengers on the great wind highways above our heads. Some drift lazily. Others barrel across the sky like they've got a dentist appointment they're late for. Watching clouds is like eavesdropping on a conversation you'll never fully understand. But you can learn to interpret the tone. A sky full of high, thin, cirrus clouds. That's polite foreshadowing. Something's probably on the way. A thick deck of nimstratus. Prepare for a moody, soggy afternoon. Towering cumulus with dark bases. Someone's throwing hands later. There are even clouds with special talents. Lenticular clouds look like flying saucers and form near mountains shaped by air flowing over ridges. Mammothous clouds dangle from the sky like pouches. Soft and ominous. Often seen after severe storms. And then there's no clouds. Rare high-altitude beauties that glow in twilight like the sky's secret jewelry. You can spend your whole life watching clouds and never see the same scene twice. They're never still. Never silent. They're the sky's storytellers. Mood setters. Cryptic messengers. I've read more weather from the shape of a morning cloud than from a dozen radar screens. There's something deeply human about cloud watching. We see shapes, stories, symbols, a dragon, a ship, a face we miss. Clouds become our thoughts projected into the sky. I suspect the sky enjoys the attention. Even in sleep, clouds remain active, blanketing cities, drifting over forests, casting moon shadows on snowfields. They wrap the earth in softness and mystery, a reminder that the world above is as alive as the world below. So tonight, as you close your eyes, imagine the sky overhead, layered with drifting vapors, some thick and brooding, others delicate and aloof. Let your thoughts rise like warm air, condense into dreams, and float gently into the arms of sleep. Rain. The skies melt down in droplet form. Now, let's talk about something deeply emotional, universally experienced, and occasionally romanticized by poets who have clearly never had wet socks. Yes, darling, it's time for rain. Rain is the sky crying, but in the most technical and physics-driven way possible. It's what happens when the atmosphere can't hold it together. Literally, it builds. It stews. And then it just lets go. A full-blown sky sob. Let's start at the very beginning. Remember our friends. The clouds. Floating collections of tiny water droplets or ice crystals. They're basically moisture hoarders. But even hoarders have limits. When cloud droplets get too crowded, too heavy, or just plain overwhelmed by their own volume, they start to combine. Droplet meets droplet. They merge. They grow heavier. Gravity, which has no chill whatsoever, pulls them down. And down they fall. That's rain. But not just any falling water counts. To be officially declared rain, the droplets need to be big enough to reach the ground without evaporating on the way. If they're too small, they might fall a bit and then ghost you completely, evaporating before they ever hit the ground. That's called ver. And yes, the sky is totally capable of teasing. So rain begins with condensation. Water vapor in the air cooling and clinging to particles like dust, pollen, or whatever mysterious gunk is floating around up there. These particles are called condensation nuclei, which sounds very official, but really they're just atmospheric cling film. Without them, rain can't happen. No nucleus. No party. Once enough droplets come together and grow heavy, gravity takes the res. They fall. How fast they fall depends on their size. Big drops plummet. Small ones drift. Raindrops don't actually look like teardrops. By the way, that's just artistic nonsense. In reality, small raindrops are nearly spherical. Bigger ones flatten out on the bottom like tiny flying pancakes. If they get too big, they break apart mid-fall. Dramatic. Rain comes in many flavors. Drizzle is the polite kind. Barely a mist. The sky's way of saying, I'm not mad. I'm just disappointed. Showers are the chaotic kind. Off, sudden, and typically happening when you leave your umbrella at home. Then there's steady rain. The persistent, relentless type that starts and just doesn't stop. That's the emotional monologue of the weather world. You know, the type of rain depends on the kind of cloud it falls from. Stratus clouds give us drizzle, low gray, slow leak skies. Cumulonimbus clouds are the drama queens dropping torrential rain with thunder and lightning as supporting casts. Nimbostratus clouds are the ear of the atmosphere. Gloomy, drippy, and always present when you forget to waterproof your shoes. Rain can form in different ways. 2. Sometimes warm air is forced up over cold air. As in frontal rain. Classic. Civilized. Very British. Sometimes air is forced up by mountains. Called orographic rain. Which is fancy talk for mountains make things damp. Then there's convective rain. Where the sun heats the ground. The air rises fast. And kaboom! You've got afternoon thunderstorms blowing through your barbecue. And yes, rain has smell. You know that fresh earthy scent when it starts to fall. That's petroor. A delightful little term for the oil released from soil and plants when raindrops hit the ground. It's the earth exhaling or sneezing depending on the intensity. Now, let's address a few awkward rained myths. No, you can't catch a cold from rain. Wet hair might ruin your day, but it won't compromise your immune system. And no, rain is not always clean. Those droplets pick up whatever's floating in the atmosphere. Pollution, dust, maybe even microscopic bug parts. Enjoy. There's also acid rain, which, yes, sounds like a cool name for a rock band, but is actually a result of air pollution. Sulfur dioxide and nitrogen oxides mix with water vapor, forming acidic droplets that fall to earth and make everything a bit more tragic. It harms ecosystems, buildings, and moods. Thankfully, emissions controls have helped reduce this in many regions. But it's a reminder that rain, like people, absorbs the energy it's surrounded by. Rain can bring relief or ruin. Farmers pray for it. Vacationers curse it. Lovers dance in it. Cats hiss at it. It fills rivers, waters crops, and sometimes floods basement. Entire civilizations have risen and fallen around seasonal rains, or the lack of them. One of the most poetic things about rain is how democratic it is. Touches everything. It falls on rooftops and treetops, on sidewalks and skylights. It blurs the edges of the world. And at night, there's nothing quite like the sound of rain on a roof. Steady. Soothing. The atmosphere's lullaby. It wraps the world in a soft, rhythmic hush. The sky version of a shush. So now, as you settle into sleep, imagine a steady rain falling outside. Picture droplets tapping gently on windows, sliding down glass in slow motion races, pooling on pavement, soaking into soil. Every drop is a story, a molecule's journey from vapor to gravity's embrace. Rainbows, the sky's dramatic apology note in full color. Now we drift out of drizzle and into dazzle. The storm has passed. The clouds are parting. And suddenly there it is. A glowing arc painted across the sky like the atmosphere's idea of a peace offering. Let's talk about rainbows. The most theatrical, scientifically sassy side effect of rain you'll ever see. Rainbows are proof that the sky, while prone to tantrums, also has flair. You could be trudging through a soggy Tuesday and then bam. There's this multicolored arc hovering in the air like a divine screensaver. They feel magical, mythical, instaearthy. But behind that shimmer and sparkle, good old-fashioned physics. To understand rainbows, we need 3 ingredients: sunlight, raindrops, and the perfect angle. Without those, you just have wet ground and a grumpy sun. Here's what actually happens. Sunlight enters a raindrop and slows down, bending as it moves from air, less dense, into water, more dense. This bending is called refraction, a word that sounds suspiciously like something from a wizard's glossary. Inside the raindrop, the light reflects off the back and then refracts again as it exits. That double bend is what breaks sunlight up into its component colors like a prism. Boom. Rainbow. But the magic isn't over yet. See, different colors bend at slightly different angles. Red bends the least, violet the most. So, the light fans out into a spectrum, forming a circular arc. An arc because all the raindrops at just the right angle, about 42 degrees from your line of sight, are reflecting light back at you. You're only seeing the ones in the perfect spot to make the rainbow visible from your perspective. That's right. Every rainbow is yours. It's a one-person optical illusion. The person standing next to you, they're seeing a different rainbow. Rainbows are inherently personal. Isn't that a deliciously sentimental fact? Now, about those colors. Traditionally, we say there are 7: red, orange, yellow, green, blue, indigo, and violet. Good old Roy G. Biv. But in truth, the spectrum is continuous. There are no strict lines between the colors. We just like putting things in categories so we don't panic. Indigo, for instance, is kind of the middle child between blue and violet. Some scientists claim it doesn't deserve its own spot. Indigo has since applied for emotional compensation. Sometimes, if you're lucky or just standing near a unicorn, you'll spot a double rainbow. This happens when light reflects twice inside the raindrop before exiting. The second rainbow is fainter, flipped in color order, and spaced a bit farther out, around 50 to 53 degrees. It's like the rainbow's shadow clone. Moodier, more mysterious, desperately hoping you notice it. But wait, there's more. Occasionally, you'll see faint extra bands on the inside of the main rainbow. These are supernumers, the result of interference patterns in the light waves. Yes, the atmosphere is out here doing quantum-level theater and not even charging for tickets. Rainbows can appear in all sorts of odd places. Mist from waterfalls, spray from ocean waves, even the fine haze around a garden hose if you stand just right. Anywhere there are suspended water droplets and sunlight, the potential for a rainbow exists. Nature is practically throwing glitter at you. There's also the rare and haunting moonbow, A rainbow formed by moonlight instead of sunlight. They're faint, ghostly, often colorless, like a dream someone half remembers. I've seen one once in the Scottish Highlands standing barefoot in dew and probably hypothermic. Worth it. Of course. Rainbows have long been the subject of legends and law. Norse mythology called it a bridge to the gods. Irish folklore threw a pot of gold at the end of it and unleashed a small army of suspiciously protective leprechauns. In truth, you can never reach the end of a rainbow because it moves with you. It's not a thing in space. It's an angle, a dance of light and perception. The end of the rainbow is always just out of reach. Like your celebrity crush who regularly shows up in your dreams. And yes, we've tried to chase them. Meteorologists study rainbows to learn about the size of raindrops. Artists paint them. Poets weep over them. Tourists try to selfie them, usually with their thumb over the lens. And somewhere a meteorologist with a degree and a vendetta is trying to explain patiently that rainbows do not need filters. But perhaps the best thing about rainbows is their timing. They don't show up before the rain. They don't hover during the downpour. They appear after. They're the sky's way of saying, okay, I was a bit much. Here's a peace offering. Let's be friends again. They're not just beautiful. They're comforting. A reminder that light still exists, that storms don't last forever, and that even water droplets can become art under the right conditions. So tonight, as you close your eyes and drift into dreams, imagine a sky just washed clean by rain. The clouds part. The sunlight peeks through and there arching across the horizon is a ribbon of light refracted. Reflected and radiant just for you. Lightning and thunder when the sky throws a rave and yells about it. Darling, brace yourself. This chapter isn't soft or fluffy. It's electric. It's loud. It's the atmosphere in full-blown meltdown mode. Because while rain whispers and rainbows twinkle, lightning and thunder stomp in like headlining rock stars at a weather festival. This, dear sleeper, is when the sky parties too hard. Let's start with the big question. What even is lightning? It's not just a zap or a flash or Zeus chucking glow sticks from Mount Olympus. Lightning is electricity. Massive. Terrifying. Beautiful electricity born from a storm cloud having a complete electrical breakdown. Picture a thunderstorm cloud. Specifically a cumulonimbus. Our old moody friend. Inside this towering monstrosity, water droplets, ice crystals, and bits of hail are bumping into each other like bumper cars in a frozen disco. These collisions create separation of charge. The top of the cloud becomes positively charged. The bottom becomes negatively charged. And all that imbalance. It's not sustainable. Nature hates imbalance. So what does the cloud do? Throws a fit. That's lightning. Lightning is the atmosphere desperately trying to even things out. It's a sudden violent flow of electricity. Millions of volts surging to restore balance. Sometimes it travels from cloud to cloud. Sometimes from cloud to air. But the most dramatic kind, the one we care about, is cloud to ground lightning. That's when the charge builds up so much that the sky reaches down and slaps the earth. But wait. It gets better. Lightning doesn't just zap and go. It prepares before the visible flash. A stream of negative charge snakes down toward the ground in a jagged, invisible path. This is called a stepped leader. And it looks like lightning trying to pick which part of the planet to sass. Meanwhile, the ground responds with its own positive streamers rising up like desperate hands at a concert. When the two connect, bam! The return stroke surges upward and that is the flash you see. It's hot. Like really hot. Roughly 30,000 Kelvin. That's 5 times hotter than the surface of the sun. A brief moment of plasma brighter than anything around it. Then gone. And then comes the thunder. Thunder is the sound lightning makes when it realizes what it just did. That bolt of plasma heats the surrounding air instantly, causing it to expand explosively. The air doesn't politely step aside. It erupts, sending out a shock wave that we hear as thunder. It's not the lightning itself making noise. It's the air reacting to it like it just saw its exam results. You see the flash first because light travels faster than sound. The farther away the lightning, the longer the delay before the thunder arrives. That's why you count seconds after a flash. Every 5 seconds equals about a mile of distance. Lightning flash. 1 Mississippi. 2 Mississippi. Boom. It's the sky's own countdown timer. Lightning can strike miles away from a storm cloud. These are called bolts from the blue. And they are exactly as rude as they sound. They arc out horizontally from a storm and then crash down far from the actual rain. It's the meteorological equivalent of getting hit with a water balloon from someone else's backyard. Now, let's clear up a few myths. No, lightning doesn't always strike the tallest object. But it often does because tall things are just closer and more tempting. And yes, metal conducts electricity. But being wet is actually the bigger issue. Water conducts electricity beautifully. Standing in a puddle during a lightning storm is basically yelling, "Pick me!" to the sky. You can get lightning without rain. Dry lightning. Extra terrifying. You can also have thunder without visible lightning if the flash is obscured by clouds. And yes, there are different types of lightning. Forked lightning. Sheet lightning. Ball lightning. Weird and rare like the weather's attempt at paranormal activity. And the truly bizarre sprites and elves. Flashes that occur high above thunderstorms too delicate and eerie for most eyes. And then there's the danger. Lightning is powerful. It kills. It sets things on fire. It fries electronics. And it has absolutely zero remorse. That's why we have lightning rods. Metal spikes that safely conduct the electrical current into the ground. They don't attract lightning. They just give it a polite exit strategy. Despite its danger, lightning is essential. It helps fertilize soil by fixing nitrogen in the atmosphere. Clears the air. It maintains the planet's electric balance. And let's be honest, it's gorgeous. A thunderstorm rolling across a landscape lit by flickering bolts is nature's most unapologetic flex. So as you lie in bed, safe and dry, imagine the towering storm clouds far away. Imagine the sky rumbling with energy. A flash lights the clouds like a camera bulb from the heavens. Then crack. The thunder rolls across rooftops and valleys, echoing off mountains, shaking windows, stirring dreams. It's loud. It's dramatic. It's pure atmosphere. Storms when the sky throws all its furniture out the window. You brave soul. You've weathered rain, wind, lightning, and even the occasional rainbow-induced existential crisis. And now we arrive at the main event. Storms. When the atmosphere decides that a little bit of everything simply isn't enough. Now, dear dreamer, we step into the roaring, swirling, utterly unhinged world of meteorological mayhem. What is a storm? Technically, it's any disturbed state of the atmosphere involving strong winds, rain, thunder, lightning, or snow. But that's like calling a dragon a reptile with a heat problem. A storm isn't just a thing. It's a scene. It's where the sky gets emotional, shoves air masses around, and hurls moisture at the ground in an operatic fury. Storms start with instability. The atmosphere becomes restless like a toddler full of juice boxes and poor decisions. Warm air rises. Cool air sinks. Moisture gets pulled upward. As the warm, moist air rises, it cools and condenses into clouds, releasing energy that powers the updraft even more. Think of it like the sky building its own chaos engine. And once that engine starts, it doesn't want to stop. The result? A storm cell. This is the fundamental unit of storminess. Some cells are mild, just a quick burst of rain and thunder. Others organize into lines, clusters, or full-blown atmospheric riots. Let's take a brief stroll through the stormy zoo, shall we? First, we have your basic thunderstorm. It brings rain, thunder, lightning, and sometimes hail. These can be short and dramatic or long and muttering depending on how angry the atmosphere feels. Next, the multicell storm. A group of storm cells working in tandem like a gang of slightly uncoordinated acrobats. They feed off each other's updrafts, take turns throwing tantrums, and move across the landscape like a traveling weather circus. Then there's the supercell. Oh, darling. This is the Beyoncé of storms. Big, bold, and capable of generating everything from softball-sized hail to tornadoes. Supercells have a rotating updraft called a mesocyclone, which is every bit as terrifying as it sounds. These storms don't just pass through. They announce themselves, tear up the lawn, and refuse to leave. A particularly fun trick some storms pull is hail. Frozen balls of pain that fall from the sky like meteorological marbles. Hail forms when strong updrafts keep lifting water droplets into freezing regions of the cloud layer by layer until they're too heavy and come crashing down. It's nature's way of saying you thought rain was annoying. And then we have the squall line. A long, narrow band of thunderstorms marching across the land like a disgruntled army. They bring high winds, intense rainfall, and occasionally a sinister greenish tint in the sky that says, "Don't ask questions. Just go inside." Let's not forget DRO widespread, long-lived windstorms associated with fast-moving thunderstorms. Unlike a tornado which spins and shreds, a direct show smacks everything flat in a straight line. It's like the sky swinging a giant weather plank. Storms can also bring flash floods when rain falls faster than the ground or drains can handle. These are particularly treacherous because they arrive with no warning, fill roads and basement, and generally ruin everyone's Tuesday. And of course, we must talk about the storm surge. A coastal storms plus one guest that no one invited. During hurricanes or intense storms over the sea, wind pushes water toward the shore, raising sea levels dramatically. This isn't just a puddle. It's a wall of ocean, a rude, salty ambush. What fuels all this chaos? Heat and moisture. Warm air can hold more water vapor. And the more water vapor you have, the more fuel your storm gets. Add wind shear, differences in wind speed or direction with height. And now you've got rotation. You've got structure. You've got a very angry sky beast with an agenda. Despite all this drama, storms follow patterns. They're studied, modeled, forecasted. Meteorologists watch them like hawks with PhDs using radar satellites, weather balloons, and the occasional unlucky intern with a notepad. And yes, storms can be beautiful, terrifying, yes, but beautiful. The flicker of lightning in a distant cloud, the deep rolling growl of thunder over hills, the scent of ozone and rain-soaked earth, even the eerie calm just before the first drop falls. Nature holding its breath. So what do you do during a storm? You respect it. Stay indoors. Unplug your electronics. Light a candle if the power flickers. Sip tea. Read a book. Listen to the rain hammering the roof and be grateful for walls. The sky is out there throwing its furniture around you. Wise sleeper. Are tucked in and safe. As you drift into sleep, let the sounds of a remembered storm play softly in your imagination. The patter of rain. The rumble of distant thunder. The occasional flicker of brilliance in the sky. The world alive. Agitated. Expressive. Fog and mist. The sky-cozy obsession with personal space. After the thunder, the lightning, the flying branches, and soggy socks, we enter a gentler mood, a quieter place, a little moody, a little mysterious. Fog is weather's version of a clingy friend. Soft, persistent, and suddenly right in your face with no warning. Doesn't shout or crash or roar. It just appears and says, "You won't be seeing much today. You're welcome." Technically, fog is a cloud that touches the ground. That's it. Same physics. Same water droplets. Same cozy chaos. Instead of floating majestically through the sky, these droplets hang out at ground level and pretend to be mysterious. Think of it as sky soup. Atmospheric low-hanging drama. So, how does fog form? It's all about cooling. When warm, moist air cools down to its dew point, the temperature at which air becomes saturated. The moisture condenses into tiny water droplets. If this happens near the ground, congratulations, you've just grown some fog. Don't breathe too hard or you might scare it. There are different types of fog. Of course, because the atmosphere loves variety. There's radiation fog, which sounds more dramatic than it is. This one forms overnight when the ground cools quickly under clear skies. The air right above it cools, too, and poof, fog. It usually hugs low valleys and quiet fields like nature, tucking itself in with a vaporous blanket. Then there's advection fog, which happens when warm moist air moves over a cooler surface like sea air rolling inland. This is common near oceans and coasts. This is why San Francisco is basically a fog theme park. We also have upslope fog, which creeps up hills and mountains as moist air is forced to rise and cool, and evaporation fog, which forms when cold air moves over warmer water, causing the water to evaporate and then immediately condense. Picture lakes steaming in autumn like they're trying to start a poetry blog. Now you may ask, what's the difference between fog and mist? Not much really. It's a visibility issue. If you can see more than a kilometer ahead, it's mist. Less than that, fog. In other words, mist is fog that hasn't fully committed. Fog is mist that brought a book and refuses to leave. Driving in fog can be, let's call it, an experience. It swallows landmarks, eats headlights, and turns roads into ghost stories. Which is why fog lights exist angled low to reduce reflection off the suspended droplets. If you've ever driven through thick fog at night, you'll understand why people write eerie novels about it. Fog doesn't just obscure your surroundings. It alters your perception. Sound gets muffled. Distance feels off. Time slows down. It's like the world forgot to finish rendering. And yet, fog is deeply poetic. It shrouds the ordinary in mystery. It quiets the world, softens it. Cities hush. Forests vanish and reappear. A single street lamp in fog can feel like a portal. There's even freezing fog because the atmosphere likes to keep things spicy. This happens when supercooled water droplets freeze on contact with surfaces, coating everything in delicate ice crystals. It's beautiful and also deadly if you're, say, walking, biking, or existing near anything that can become slippery. Fog plays a crucial role in ecosystems. In certain coastal deserts like the Atacama or Namib, fog is life. Plants and insects collect moisture directly from it. Humans, too. Fog catchers, fine mesh nets, are used to harvest fog water in arid regions. It's not just ambience, it's hydration. And like most weather, fog eventually lifts. The sun rises, the air warms, the droplets evaporate, and the world comes back into view. Buildings reappear, trees regain definition, reality returns. But for that brief time you existed in a soft glowing dream. So tonight, as you close your eyes, imagine fog curling around lampposts, drifting across empty fields, gently settling into the crooks and corners of the world. Everything softened, everything slowed. The sky just for a little while pulled close around you like a shawl. Snow. The sky frozen confetti and silent statement piece. Now we head into winter's arms, into flurries and flakes. Frostbite and fairy tales. The storm has passed. The fog has lifted. And now the sky decides it's time to get artistic. Let's talk about snow. The frozen whisper of the clouds. The sky slow motion applause. Snow is what happens when clouds decide that rain just isn't glamorous enough. It's water vapor that freezes and crystallizes high in the atmosphere, drifting to the ground as tiny six-pointed sculptures. Delicate, deadly, delightfully inconvenient. To get snow, you need three things: cold temperatures, moisture, and patience. The air needs to be below freezing, not just at the surface, but all the way up through the cloud layers. If even a thin slice of warmer air sneaks in, snowflakes can melt mid-descent and show up as sleet, freezing rain, or just damp disappointment. True snow is an unbroken chain of cold, cloud to ground. Now, how does a snowflake form? It begins with a speck, particle of dust or pollen or even bacteria. Yes, bacteria. Weather is weird. Water vapor in the cloud clings to the speck and freezes. More vapor deposits onto it layer by layer. Growing arms, branches, tiny extensions. Because of the structure of water molecules and the geometry of ice, snowflakes always grow in six-sided symmetry. Always. The hexagon is nature's favorite snowflake shape, probably because it fits nicely and throws excellent shade. And the variety, endless. No two snowflakes are exactly alike. And that's not just poetic fluff. It's physics. The temperature, humidity, wind, and path each flake travels determine its final form. Plates, needles, dendrites, columns. Snowflakes have types. The clouds had yearbooks. Snowflakes would definitely win, most likely to be breathtaking under a microscope. Snowflakes fall slowly, typically at a dreamy pace of about 1 to 4 miles per hour. This gives snow its magical quality. It drifts. It flutters. It ignores gravity's usual urgency. It makes everything feel slower, quieter, softer. Snow muffles sound. That's not your imagination. It really absorbs and scatters sound waves. That's why snowy mornings feel stiller, like the world is holding its breath. Streets go quiet. Trees stand taller. Even the chaos of modern life seems to hush under a blanket of white. But snow isn't always gentle. Blizzards. Those are snow's angry cousins. They're not just heavy snowfalls, but storms with strong winds, low visibility, and a sense of vengeance. You can't see more than a few feet. The snow stings. Your scarf freezes mid-wrapping. Blizzards don't play. Then there's lake effect snow. This happens when cold air sweeps over a warmer lake, scoops up moisture, and dumps it as snow on the other side. This is why areas near large lakes can get absolutely buried while towns just a few miles away remain snowless. It's meteorological favoritism, and it is brutal. Snow can be dry or wet. Dry snow is powdery, fluffy, beloved by skiers, and loathed by people trying to shovel. It doesn't pack well and blows around like caffeinated glitter. Wet snow is heavy, sticky, and excellent for snowballs, snowmen, and breaking tree branches. Snow transforms landscapes. Hills become sculpture gardens. Streets become memory foam. Cities wear white like they're posing for a seasonal postcard. Even the ugliest rooftop gains some dignity under a soft dusting of snow. But with beauty comes danger. Snow hides ice, piles up on power lines. It freezes pipes, cancels flights, and turns commutes into Arctic obstacle courses. Every winter, entire populations relearn how not to fall on their driveways. Boiler. Most still fall. And yet, snow inspires. It's in lullabies, legends, and literature. It brings out joy. Children race outside to catch flakes on their tongues. Adults pretend they're too old to do the same. Then do it anyway. Entire days are canceled for it. When was the last time rain got you out of school? There's even a word for the glow that snow creates under a cloudy sky at night. It describes that soft luminous quality. The world lit from below. Street lights reflect. Everything glows slightly. It's uncanny. Dreamlike. A secret light. And snow has sound. Not just the silence, but the crunch under boots. The hiss as it hits a warm window. The sudden whoosh as a tree unloads its branches. The world under snow isn't silent. It's whispering. So now, as you drift into sleep, picture the sky filling with tiny crystalline dancers. Each flake unique. Each one on a journey. Imagine them falling across rooftops, treetops, empty fields, city streets. A soft invasion. A quiet gift. A message from the clouds saying, I've cooled off. Let's blanket the world. Hailstones. When the sky loses its temper and throws ice at you. If you made it through snow with your romanticism intact. Now we're turning up the intensity. No more gentle flakes. No quiet hush. We talk about hailstones. The sky's version of I've had enough of this. Served ice cold and at terminal velocity. Hail is not subtle. It doesn't whisper. It doesn't drift. It arrives with force, noise, and often a desire to shatter windcreens. While snow is the sky's way of gifting you frozen lace. Hail is a sky tantrum with weaponized marbles. So, how does it form? To understand hail, you have to enter the belly of the beast. The thunderstorm, specifically, a powerful cumulonimbus cloud. The towering, seething skyscraper of the weather world. These clouds have immense vertical development. Meaning air is constantly rising and falling inside them like an elevator operated by a caffeinated squirrel. Within that cloud, warm, moist air rises as it ascends. The moisture condenses and cools, releasing energy that powers the storm. But the real magic or menace begins when droplets of water are swept upward into sub-freezing regions of the cloud by strong updrafts. Those droplets freeze. They become tiny ice pellets. And then they fall. But not all the way. The storm says, nope, and hurls them back upward with another powerful updraft. Up they go, meeting more moisture, gathering more layers of ice. This process repeats up, down, up again, like a freezing yo-yo on a growth spurt. With each trip, the hailstone gets bigger. More water freezes onto its surface in concentric layers. This is called accretion, which sounds like a fancy legal term, but really just means layering up until you're too big to ignore. Eventually, the updraft isn't strong enough to keep the hailstone aloft. Gravity wins. The stone falls and falls fast. Now, how fast it falls depends on its size. Tiny hailstones might flutter down like icy cereal. Larger ones can plummet at over 100 miles per hour. The biggest hailstone ever recorded in the US was nearly the size of a volleyball. Imagine a frozen grapefruit crashing into your picnic. Romantic, right? Hailstones are usually round or lumpy. Cut one open carefully and you'll often find rings like tree trunks. But with more drama. Each ring is a freeze. The referee's cycle. It's a record of the hailstone's chaotic life. So, where do we get the worst hail? Places with strong updrafts and lots of unstable air like the central US. Argentina, Bangladesh, and parts of China. These areas are hail hotspots, especially during spring and summer when the atmosphere loves to stir the pot. And hail doesn't travel alone. It often shows up mid-thunderstorm accompanied by heavy rain, gusty winds, and the occasional lightning bolt for flair. It damages crops, cars, roofs, windows, and occasionally human dignity. So, how do you know hail's coming? Radar. Mostly meteorologists look for hail signatures. Areas in the storm where the reflectivity suggests dense, icy precipitation. Sometimes storms even have a specific radar pattern nicknamed a hail spike. Sounds cute, isn't? And no, those golf ball-size warnings aren't metaphors. Meteorologists actually size hail using familiar objects. Sized. Marbles-sized. Golf ball. Ping pong ball. Tennis ball. Baseball. And once you're into grapefruit territory, stay indoors and make peace with your insurance company. Interestingly, not all hail reaches the ground. If the air beneath the storm is warm enough, smaller hailstones can melt on the way down, turning into heavy raindrops or slushy misery. But when it's cold enough all the way down, buckle up. There are also soft hail and grapple snowflakes that collected rime frosty water droplets and turned into lumpy little ice puffs. Not as aggressive as true hailstones, but still solid enough to ruin a crossall. And despite their destructive nature, hailstones are fascinating. Each one is a frozen biography, a record of the storm's intensity, a snapshot of the sky's mood at that very moment. They fall fast. They melt quickly. But for that brief, brutal instant, they are the most dramatic object in the atmosphere. So now, as you tuck yourself into bed and listen to the quiet world outside, know that sometimes the sky gets loud. Sometimes it throws a fit, and sometimes that fit takes the form of frozen spheres tumbling from thousands of feet above. But tonight it's calm. No rumbles. No crashes. Just the memory of a storm that once threw glitter-coated rocks and the knowledge that you are safely indoors and out of range. Tornadoes. The sky spinning. Screaming tantrum in funnel form. If you've made it this far, you've survived the snow, the hail, the fog, and possibly an existential drizzle. Now we're entering the realm of pure atmospheric chaos. No fluff. No fluffing. Just wind. Spinning. Screaming. And occasionally picking up cows. Tonight's drama is brought to you by the mighty, menacing, occasionally misunderstood tornado. Tornadoes are where the sky stops whispering and starts flipping tables. They are rotating columns of air, violently extending from the base of a thunderstorm to the ground. They spin fast. They move unpredictably. They destroy things. And yet there's something hauntingly beautiful about them. A kind of terrible elegance. A pirouette of doom. To understand tornadoes, you first have to understand supercells. The big bad thunderstorms we met in Chapter 10. Not every tornado comes from a supercell, but most of the dramatic long-lived Hollywood-level ones do. Inside a supercell, you've got warm, moist air, surging upward. That's your updraft. And cooler, drier air sinking downward. Downdraft. At wind shear. That's when winds change speed or direction with height. And now you've got horizontal rotation forming in the lower atmosphere. Picture a giant invisible rolling pin of air. Then the updraft lifts this horizontal spin vertically. The column stretches. It narrows. And suddenly the storm has a messy clone. A rotating updraft that may go on to spawn a tornado. It's like the thunderstorm has decided to grow its own weather appendage. A spinning one. But here's the twist. Pun entirely intended. Not every meocyclone becomes a tornado. Conditions have to be just right. And even when one does form, it usually begins invisible. Funnel cloud. A cone of rotating air descending from the cloud base. It only becomes a tornado when it makes contact with the ground. What do tornadoes look like? All kinds. There are thin snake-like ones. Graceful. Sinister dancers. There are fat wedge-shaped beasts wider than they are tall. Some look like stovepipes. Some like ropes. Some split and reform. Some vanish after 60 seconds. Others stay on the ground for hours. Tornadoes are chaos with a rotation index. And they're fast. Winds inside a tornado can exceed 300 miles per hour in extreme cases. That's faster than most sports cars and nearly every bird. They can hurl debris miles away. flatten buildings, and strip bark from trees. Some are barely noticeable. Others reshape landscapes. Tornadoes are rated on the Enhanced Fuji scale, EF scale, a system from EF0 to EF5 based on damage observed. An EF0 might topple a few trees and EF5 is catastrophic. Homes gone. Asphalt stripped. Trucks tossed like toys. EF5s are rare. But when they appear, they rewrite local history. Where do tornadoes happen? Technically all over the world. But the undisputed champ is the United States, particularly Tornado Alley, a swath of land stretching roughly from Texas to South Dakota. The geography there is perfect for tornado breeding. Warm Gulf air meets cold northern air with little to no mountain interference. Boom. Sky blender. Other tornado hotspots include parts of Argentina, Bangladesh, Canada, and even the UK, though British tornadoes tend to be polite and underachieving. Now, how do you detect a tornado? Radar is the primary tool, especially Doppler radar, which detects rotation within a storm. Forecasters look for telltale hooks in the radar signature called hook echoes. These indicate the swirling structure where a tornado might form. But still, tornadoes can form quickly. Very quickly. That's why we have watches. Conditions are favorable and warnings. One is happening or imminent. If you hear a siren and the clouds look like they're plotting something, don't wait. Get to shelter. Basement. Interior rooms. Avoid windows. And for the love of clouds, do not go outside to film it. The tornado does not care about your TikTok. There's even such a thing as a tornado family. A series of tornadoes spawned by the same supercell. Sometimes one fades as another forms. Overlapping slightly. It's like a tag team event. Only louder. And the aftermath. Haunting. Tornadoes carve scars across the land. Sweds of destruction that follow their narrow twisting paths. One house untouched. The next reduced to splinters. It's arbitrary. Cruel. And awe-inspiring. And yet tornadoes, like all weather, are not evil. They're not vengeful. They're natural phenomena. Expressions of instability and imbalance. Dramatic. Absolutely dangerous. Unquestionably. But not personal. Just physics wrapped in theatrics. So now, as you curl under your blanket, picture the sky winding down after a long stormy day. The clouds are settling. The air is still. Somewhere far away. The wind may still be turning. But here and now, you're safe. You're still. The vortex is elsewhere. Hurricanes. When the ocean makes a monster and gives it a name. Well, now, my brave and curious sleeper, it's time for something big. You've weathered the blizzards, dodged hail, fog-walked in style, and survived tornadoes spinning like the sky's espresso machine short-circuited. But now we board the swirling juggernaut of atmospheric drama known as the hurricane. This is not a breeze. This is not a drizzle. This is the ocean's fury turned rotational. A vast spiraling storm that forms over warm water, grows stronger by the hour, and then marches across seas and coasts with the self-importance of a celebrity scandal with a name. Always a name. So, what is a hurricane? Technically, it's a tropical cyclone, a low-pressure system that forms over warm tropical waters, fueled by heat and moisture, and structured around a rotating center. In the Atlantic and Northeast Pacific, we call it a hurricane. In the Northwest Pacific, typhoon south of the equator, cyclone, different names, same beast. To grow a hurricane, you need 5 things. Warm sea surface temperatures at least 26.5 degrees Celsius or 80 degrees Fahrenheit. A pre-existing disturbance like a thunderstorm cluster. Low vertical wind shear so the storm doesn't get torn apart. high humidity in the mid-troposphere, and a location at least a few degrees off the equator so the Coriolis effect can get involved and give it that signature spin. Once those boxes are ticked, bam, the atmosphere opens a new project file. It's go time. At the center of the hurricane is the eye, a deceptively calm zone, often clear and eerily quiet. Surrounding that is the eye wall, which is where the party gets violent. The eye wall hosts the strongest winds, heaviest rain, and most concentrated rage. Outside of that, spiral rain bands arc outward like the storm's outstretched arms, slinging squalls, gusts, and flash floods across vast distances. A mature hurricane is enormous, hundreds of miles across, can sustain wind speeds over 150 miles per hour, and dump over 1 trillion gallons of water per day. That's not hyperbole. That's math. These storms are engines of energy converting warm ocean water into rotating atmospheric rage with stunning efficiency. And yes, we name them because when something this big shows up, you want to remember it. Naming started officially in the 1950s for tracking purposes and public awareness. The names cycle through alphabetical lists alternating between male and female names and reused every 6 years unless a storm is particularly catastrophic. In that case, the name gets retired out of respect and fear. Hurricanes are categorized by the Safiya-Simpson scale, ranging from Category 1, nasty, to Category 5, biblical. But don't be fooled. Category 1 can still knock down trees, ruin rooftops, and make insurance adjusters cry. And sometimes it's not the wind that does the most damage. It's the storm surge. Storm surge is a hurricane's silent weapon. As the storm pushes water ahead of itself, sea levels rise dramatically along the coast. Combine this with high tide and coastal communities get swallowed whole. Add torrential rain and you've got inland flooding to match. Add wind and the trees start writing poetry with your windows. Despite all this destruction, hurricanes are meticulously monitored. Satellites track them from orbit. Aircraft, specifically hurricane hunters, fly into them, taking measurements. These brave souls, armed with sensors and strong stomachs, collect the data that lets forecasters warn the world. Forecasting has improved. We can often see a hurricane forming days in advance. But intensity prediction, figuring out exactly how strong a storm will become, is still tricky. A hurricane can strengthen overnight, going from, that's interesting, to board the windows and grab the cat in less than 24 hours. And yet, hurricanes are not villains. They redistribute heat from the equator toward the poles. They stir the ocean. They even help regulate global temperature. Destructive, yes, but also part of Earth's grand balancing act. There's also a strange beauty to them. Seen from space, they look like colossal pinwheels of white, perfect spirals set against the blue. From land, they're monsters, but from above, art monsoons, the skies, seasonal mood swing with a water budget. Now, dear dreamer, we move into rhythm, not the chaotic pulses of tornadoes or the spiraling rage of hurricanes, but something larger, predictable, cyclical, a force that ebbs and flows with near clockwork certainty. We wade into the warm, wet drama of the monsoon. Monsoons aren't storms. They're not one-time events. They're seasonal wind patterns, giant atmospheric mood swings that stretch across continents, shift the balance of entire ecosystems, and decide whether crops flourish or fail. When a monsoon arrives, it doesn't knock. It marches in, drenches everything, and says, right, let's grow things or cancel your commute. Sometimes both. The word monsoon comes from the Arabic mawsim meaning season, and that's the key. Monsoons are all about seasonal shifts in wind direction caused by temperature differences between land and sea. Here's how it works. Land heats up faster than water. So during summer, the land mass gets hot, the air above it rises, and a low-pressure zone forms. Meanwhile, the ocean stays relatively cooler, maintaining higher pressure. Air moves from high to low pressure, meaning moist ocean air rushes inland. That's your wet monsoon. In winter, the script flips. The land cools quickly, becoming the high-pressure zone, while the ocean remains warmer. Now, dry air flows outward. That's your dry monsoon. The most famous example, the South Asian monsoon. Each year around June, hot air over the Indian subcontinent draws moist air in from the Indian Ocean. The winds shift, clouds roll in, and the rain begins. First to tease, then a deluge. Cities pause, villages wait, farmers look to the sky. It's not a drizzle, it's not an afternoon shower. This is months of rain, staggered, rhythmic, almost musical in its arrival and retreat. Rivers swell, rice paddies thrive, but also streets flood. Infrastructure groans, landslides happen. It's a balance. Life giver, life threatener. The monsoon brings over 70% of India's annual rainfall. Entire economies hinge on it. Crops depend on it. Urban planners dread it. Poets romanticize it. Lovers write letters in it. Everyone else gets very, very wet. And South Asia isn't alone. Monsoons occur in parts of Africa, Australia, North and Central America, and even the Southwest United States. Arizona, for instance, has a summer monsoon season that can bring epic thunderstorms and dramatic desert downpours. Even cacti need their moment. Now, not every monsoon is reliable. Some years it's late. Some years it's early. Some years it overstays. And others it ghosts the entire subcontinent. These irregularities are influenced by large-scale oceanic phenomena like El Niño and La Niña, which we'll gossip about in another chapter. A failed monsoon can mean drought, famine, and economic hardship. A too aggressive one can mean flooding, disease outbreaks, and washed-away infrastructure. Timing, intensity, and distribution matter. It's not just did it rain. It's where, when, how much, and for how long. And yet, monsoons are woven into culture, into memory, into music, rituals, and daily life. In many parts of the world, the first rain of the monsoon is a celebration. Children run into the streets. Adults sigh in relief. The earth exhales. Dust becomes scent. Trees drip with thank yous. The smell of the first rain. Petroor feels amplified. A sensory overture to a season. There are physical markers. 2. Thunderclouds rise like mountains. Frogs appear overnight. The skies stay heavy. Clothes stay damp. Your tea tastes better because everything feels more alive. But let's not romanticize too much. Monsoons can be deadly. Poor drainage systems overflow. Hillsides collapse. Electricity vanishes. Roofs leak. And yet somehow people adapt. Umbrellas become architecture. Roads become rivers. And then roads again. And every conversation starts with, has it started yet? Or is it over yet? The science of forecasting monsoons is getting better. Satellites, ocean buoys, computer models, all helping to decode this giant seasonal pulse. But the monsoon still has secrets. It listens to the ocean. It whispers with the wind. It answers to forces larger than our forecasts. So as you drift off tonight, imagine a warm wind shifting, turning, changing course. Imagine clouds gathering far offshore, thick with promise. Imagine the first drop landing on sun-baked earth and the second and the millionth. A whole season of transformation. The sky rebalancing. Tsunamis, When the ocean decides to stand up and walk in. You've danced in monsoons, stared down hurricanes, and tiptoed through Tornado Alley. Now we go deep beneath the surface. Because not all storms come from the sky. Some are born in the belly of the earth where tectonic grudges boil quietly for centuries. And when they rise, they don't just shake the ground. They move the sea. Now we meet the tsunami. Let's start with the truth. Tsunamis are not tidal waves. They have nothing to do with tides. That term tidal wave is the linguistic equivalent of calling a lion a house cat with opinions. Tsunamis are their own beast and they are terrifying. Majestic and deeply misunderstood. A tsunami is a series of long, powerful ocean waves caused by sudden displacement of a large volume of water. What causes that displacement? Usually one of three things. Underwater earthquakes. The most common source. When tectonic plates shift, they can jolt the seafloor, pushing water upward. Volcanic eruptions, especially when an island explodes or collapses. Landslides, either beneath the sea or from cliffs crashing into water. And occasionally meteorites. That's right. The cosmos can get involved. Let's all hope it doesn't. Now, here's the sneaky part. In the open ocean, a tsunami can travel at 500 to 600 mph, as fast as a jet plane. But its wave height may be only a foot or two. You wouldn't notice it from the deck of a ship. No drama, no splash, just a silent, relentless swell moving beneath you. It's a ghost train of water. But as the tsunami approaches shallower coastal waters, everything changes. The front of the wave slows down. The back catches up. Water piles up. The wave grows taller. Narrow bays and harbors can amplify it even more. What once was a ripple becomes a wall. Some tsunamis arrive as towering waves. Others, as rapidly rising floods. The sea may even withdraw first dramatically and eerily, as if sucking in a breath before roaring forward. That's a natural warning sign. If the ocean suddenly disappears, run uphill. Do not stop. Do not take selfies. The sea is not performing. It's preparing. Tsunamis are not single waves. They arrive in series. The first wave might not be the largest. Others can follow minutes or even hours later. And just when it seems like it's over, another wave can come charging in, riding the same energy from an event that happened hours ago. Hundreds or thousands of miles away, these waves carry massive energy. They don't just crash. They inundate, moving inland with terrifying speed and strength, sweeping away buildings, vehicles, trees, roads, and anything else that's not anchored to the bedrock. And even then, sometimes water becomes a bulldozer. History is full of devastating tsunamis. The 2004 Indian Ocean tsunami triggered by a 9.1 magnitude earthquake off the coast of Sumatra killed over 230,000 people across 14 countries. The 2011 Tohoku tsunami in Japan followed a 9.0 quake overwhelmed sea walls, devastated coastal towns, and led to the Fukushima nuclear disaster. These are not just natural events. They're history shapers. But we've learned tsunami warning systems now crisscross the globe. Deep sea pressure sensors, buoys, seismographs, satellites, alerts, evacuation maps, sirens. Coastal cities have drills. Beachfront hotels have signs pointing to evacuation routes. It's not perfect, but it's better. Still, time is everything. A tsunami triggered close to land might arrive in minutes. There may be no time for official alerts. That's why natural signs matter. Earthquakes, unusual sea behavior, animals acting weird. If something feels wrong, move. And don't underestimate the aftermath. Tsunamis leave behind destruction, contamination, disease risk, and heartbreak. But they also bring unity. Human chains pulling survivors from wreckage. Global aid flights. Scientists poring over new data trying to understand the sea's latest move. So tonight, as you fall asleep, imagine the deep ocean at rest. Vast, calm, the surface smooth, its energy low, but far beneath the tectonic plates drift. Shift, breathe. Most nights they sleep too, but sometimes the deep remembers it has teeth. Heat waves. When the air decides to cook everything, including you. Now we journey into the sizzling sweat-slick domain of heat waves. The weather's prolonged dry stare directly into your soul. Unlike storms, tsunamis or snow that make a grand dramatic entrance, heat waves simply settle in. They arrive quietly. Then they stay and stay and stay like the worst house guest with a sun lamp and no chill. A heat wave is a prolonged period of abnormally hot weather, often accompanied by high humidity, low winds, and a general atmospheric attitude of what air conditioning. But here's the twist. There's no universal definition. A heat wave in London might be a breezy spring morning in Mumbai. It all depends on local climate norms. The key word is abnormal. Heat above what's expected for that location and season. Sustained long enough to be deeply annoying or downright dangerous. Heat waves form when high-pressure systems get stuck over a region, creating what's known as a blocking pattern. The high pressure acts like an atmospheric lid, suppressing cloud formation and letting sunlight pour in unhindered. The ground bakes. The air doesn't rise. There's no convection, no storms, no relief. It's meteorological stagnation. The atmosphere is holding its breath and you're holding a fan and wondering why your curtains are sweating. Now, you might think, oh, come on, it's just warm weather. But no, a heat wave is not just a hot day. It's a sustained assault on the body, infrastructure, agriculture, and mental patience. Prolonged heat can cause heat exhaustion, heat stroke, dehydration, and a deep existential questioning of why you live in a place where the pavement sticks to your shoes. Cities are particularly vulnerable thanks to the urban heat island effect. Asphalt, concrete, and buildings absorb heat during the day and release it slowly at night. This means urban areas can be several degrees hotter than surrounding rural regions, especially at night when you really want it to cool down so you can sleep without fusing to your sheets. Air quality also takes a nosedive. Stagnant air traps pollutants, creating smog, worsening respiratory conditions, and making your lungs feel like they've been lightly pan-fried. During major heat waves, power grids strain under air conditioning demand. Crops wilt, reservoirs shrink, tempers flare. Even the birds look annoyed. Heat waves are also deadly. They are among the most underestimated natural hazards. The 2003 European heat wave caused over 70,000 excess deaths. The 2021 Pacific Northwest heat dome set new temperature records and led to hundreds of fatalities. These events aren't just uncomfortable. They are public health emergencies. And they're becoming more frequent, more intense, and longer lasting due to climate change. As the planet warms, the background temperature rises, making heat waves more likely and more brutal. What was once a freak event becomes a summer standard. The atmosphere has lost its temper, and now it won't stop yelling. So, how do you survive a heat wave? Hydration is key. Fans help. Shade is sacred. Avoid exertion during peak heat. Wear light, loose clothing. Keep windows closed during the day if the outside air is hotter. Open them at night if it ever cools. And most importantly, check on vulnerable people, the elderly, young children, and people with health conditions are most at risk. And yes, animals feel it, too. Birds pant. Dogs dig for cooler ground. Even the insects take shelter. Urban wildlife will drink from puddles, air conditioning runoff, Or your iced coffee if you leave it unattended. Despite the suffering, there is a strange, surreal stillness to heat waves. The roads shimmer. The trees barely move. It's too hot for noise. Too hot for urgency. Time stretches. Minds wander. Life slows to a sticky crawl. Feels like the world is on pause and someone lost the remote. But heat waves also teach us. They highlight our weaknesses, our city's poor ventilation, our reliance on power, our fragile food systems. They push us to innovate. Cool roofs, green spaces, public cooling centers. Solutions are possible, but they require planning, cooperation, and shade. Lots of shade. So tonight, as you lie under your fan or beside your air conditioning unit like it's a beloved partner, imagine the atmosphere holding its hot breath above your region. No breeze, no clouds, just pressure, sunlight, stillness, and the slow, steady tick of thermometers climbing. Northern lights when the sky puts on its best disco for no reason at all. Finally, we've earned this one. After heat waves, storms, and the occasional sky tantrum, it's time for something utterly unnecessary and gloriously beautiful. Now we tilt our heads back, way back, and gaze up at one of nature's rarest, most breathtaking, least practical performances, the Northern Lights, also known as the Aurora Borealis. Now, to be technical, and you know I always am, auroras are not weather in the traditional sense. They're more like the sky's cosmic art show thrown by the sun, painted in solar particles, and performed in Earth's upper atmosphere, weather-adjacent space flirting with our skies. Let's begin at the source, the sun. Our star is not a calm body. It's a giant boiling sphere of plasma with frequent outbursts. Sometimes it ejects clouds of charged particles into space. These are called solar winds. Occasionally the sun goes bigger and releases coronal mass ejections. CMEMs. Massive blobs of solar energy that race across space like an angry sneeze at 1,000,000 miles an hour. When these solar winds or CMEs reach Earth, they slam into the magnetosphere, the invisible magnetic shield surrounding our planet. Most of the time, the magnetosphere deflects them like a cosmic goalie. But when the solar energy is strong enough, it disturbs the field, funnels particles down toward the polar regions. And those particles collide with atoms high in our atmosphere. Boom. Aurora. Specifically, auroras happen when these charged solar particles hit oxygen and nitrogen in Earth's atmosphere. The collisions excite those atoms. The atoms get hyper. Then they calm down and release that extra energy as light. The result: curtains, ribbons, swirls, arcs, green, pink, red, violet lights that flicker and dance across the sky like the universe trying out mood lighting. And all of it happening 60 to 400 miles above your head in the thermosphere. Way beyond clouds and weather balloons. Why green? That's oxygen at lower altitudes. Red oxygen higher up. Blue and purple. That's nitrogen showing off. The color palette depends on what particle gets hit. How hard and how high. You mostly see auroras near the magnetic poles in high-latitude regions like Norway, Canada, Alaska, Iceland, and parts of Russia. In the southern hemisphere, they're called aurora australis. Same light show, different stage. The northern lights are not constant. They're fickle. They need darkness, clear skies, and the right amount of solar activity. Sometimes they shimmer softly, barely visible to the naked eye. Other times they explode into view, waving, swirling, flickering like the sky has turned into a lava lamp. There's something deeply humbling about watching an aurora. It doesn't serve a purpose, doesn't warn of anything. It doesn't water crops or warm houses. It just is a glowing reminder that Earth is part of something far bigger and stranger. Ancient cultures had their own interpretations. The Norse thought the lights were reflections from the shields of Valkyries. Some Inuit believed they were the spirits of the dead playing ball with a walrus skull. In Finland, they called it Reventuul, fox fires, believing a mythical fox swept its tail across the snow, sending sparks into the sky. Science has explained the how, but not the why. Emotionally speaking, why does something this beautiful exist? Perhaps because the universe, despite its physics and fury, occasionally indulges in a bit of performance art. And yes, you can photograph them, but cameras see them differently, more vividly. The human eye takes time to adjust, and sometimes the real magic is in how faint and ephemeral they are. A whisper, not a shout. Auroras aren't dangerous. They don't affect the weather below. But powerful solar storms can disrupt satellites, GPS, radio signals, and power grids. In 1989, a geomagnetic storm knocked out Quebec's power. In 1859, the Carrington event, the largest solar storm on record, caused telegraph wires to spark and caught papers on fire. If it happened today, well, let's not think about it at bedtime. So as you drift off tonight, picture the sky far above. Quiet, dark, fast, and then a flicker, a brush of light, color unfolding in silence. Earth's invisible shield meeting the sun's distant breath and turning it into a dance of photons and wonder. Weather forecasts, trying to outguess the sky with math, satellites, and sheer audacity. Here we are, my brave bedtime meteorologist. After 20 chapters of storms, snowflakes, sunshine, and atmospheric drama, we arrive at the grand finale. Weather forecasts, humanity's noble, often frustrating attempt to predict the sky's next move. Let's be clear. Forecasting the weather is 1 part science, 1 part sorcery, and 10 parts data. It's a constant battle against chaos driven by computers, models, and very dedicated people in lab coats trying to convince clouds to be a little more predictable. A weather forecast is simply a prediction. What the atmosphere is expected to do over a given time in a given place. Will it rain? Will it snow? Should you wear your adorable rain boots or your existentially disappointed flip-flops? These are the questions forecasts try to answer. To do this, forecasters start with observations. Temperature, humidity, wind speed, pressure, cloud cover. Thousands of measurements taken every second from weather stations around the globe. Weather balloons launched twice a day to sniff the upper atmosphere. Satellites orbiting Earth watching clouds and storms from above. Radar systems tracking precipitation in real time. Buoys floating in oceans measuring wave height, pressure, and sea temperature. All this data feeds into numerical weather models. Complex simulations of the atmosphere run by supercomputers. These models use equations from physics, thermodynamics, and fluid dynamics to calculate how air will move and behave in the hours and days ahead. These aren't guesses. They're extrapolations of what the atmosphere should do based on what it's doing right now. Of course, the atmosphere is a bit of a diva. Tiny changes, what we call initial conditions, can lead to vastly different outcomes. That's the famous butterfly effect. A small error in the data today could mean a missed thunderstorm or an unexpected blizzard 3 days from now. That's why we use ensemble forecasting, running multiple versions of the model with slightly different starting conditions to see a range of possible futures. Think of it like crowdsourcing the atmosphere's mood. Then come the meteorologists who interpret the models, factor in local knowledge, and apply good old-fashioned human judgment. Computers are great, but they don't know that your valley gets fog every time it rains 30 m away, or that the mountain near your town loves to surprise everyone with rogue snow squalls. The forecast is assembled, Today's high. Tonight's low. Chance of rain. Wind direction. Cloud cover. UV index. Pollen count. And whether your barbecue plans are doomed. This is broadcast on websites, radio, and television, often by cheerful humans with suspiciously good hair. Forecasts are more accurate than ever. A 5-day forecast today is about as reliable as a 3-day forecast was 20 years ago. We can often predict major storms days in advance. But perfection, still out of reach. Some things are easier to forecast than others. Temperature is usually solid. Rain timing, tricky. Thunderstorms, localized chaos. Snow totals. May the math gods bless your soul. And if someone tells you the weather 2 weeks from now down to the hour, run. That's not forecasting. That's fortune-telling. Still, forecasts are invaluable for agriculture, travel, emergency planning, space launches, picnics. They help us plan our lives around a sky that's famously moody. And they're only getting better thanks to machine learning, high-res models, and that little voice in your phone that says, "Bring an umbrella right before you need it." So, how should you read a forecast? Here's my sage advice. Percent chance of rain isn't how likely it is to rain anywhere. It usually means the likelihood that rain will fall somewhere in the forecast area. Hourly forecasts are rough sketches, not commandments. If the forecast says isolated storms, assume your barbecue is doomed. Mostly sunny and partly cloudy are basically the same. It's a glass half sky full situation. Forecasting is part science, part storytelling. We're trying to take the vast boiling atmosphere and turn it into a 7-day icon chart. It's wildly ambitious, often frustrating, and deeply human. So, tonight, as you close your eyes and feel the comfort of shelter around you, know that above this roof, the atmosphere is humming, shifting, breathing, and somewhere a team of humans, satellites, and supercomputers are working together to tell you what it might do next. Tomorrow brings whatever the sky decides. But for now, you're warm, dry, and maybe you even packed that umbrella. Thank you for journeying through storms, stars, sunbeams, and swirling air with me. Sleep well, you beautifully weatherwise wonder.